Okay, so good afternoon and welcome to lecture 11. So this is on analysis of variance. So analysis of variance still falls under hypothesis testing. In the previous lecture, we saw how to carry out a hypothesis test about the mean and the proportion, but all that was done on only one, when you have only one population. Okay, but analysis of variance is a method that is used to evaluate the difference between means when you have different or many populations. Okay, so this technique compares variances for the different populations. Okay, and actually it's not different because it's not different from what we have covered so far, because we already know the steps in hypothesis testing. So there are only very few differences or in some steps. Okay, so an example would be maybe testing teaching methods. Okay, so if we had online classes, say physical and another method that uses both. Okay, so if we're going to test this, we can get a population of students using these different methods of teaching, and maybe the performance in a particular test could be observed. Okay, so if we get maybe in a particular test or exam, okay, okay, so maybe a test out of 10, the online get 1, 3, 4, then physical gets 4, 2, 5, and both, okay, and 1 there, maybe 6 and 7. Okay, so if we had that table, so if we're going to compare the different teaching methods, we have students from population 1, population 2, and population 3. So the different kinds of the different teaching methods are known as treatments or factors. Okay, so these are known as treatments, and the values that we have obtained, or the values that we have put there or observed, are the levels of the treatments. Okay, so to compare this, we use analysis of variance. So the first thing to do is to realize that this is a hypothesis test, and therefore we have to follow the steps in hypothesis testing. So the first step, of course, is to formulate the null and alternative hypothesis. So for the null hypothesis, we're going to say mu1, which is for the population 1 or the teaching method 1, is equal to mu2, and that is also equal to mu3, because we have 3 teaching methods. Okay, so this will be our null hypothesis, and it is always like this. If you had 4 populations, you're going to add is equal to mu4. Okay, so this goes and up to the number of populations that you have. Okay, and the number of populations is denoted by k. Okay, so now that we have a null hypothesis, the alternative will be not all means equal. So this is always the alternative hypothesis. So you state mu1 is equal to mu2 is equal to mu3, and the alternative is always not all means are equal in words. Okay, so you can even put mu1 not equal to mu2 not equal to mu3. That is still okay. All right, so this is the first step. And the second step, we know we have to state the level of significance. So here we put 0.05 since we are not given. Okay, after that we state our rejection region. Now when we're dealing with analysis of variance, we use the F table. So in the F we have something like that, and we get our F alpha, which is our critical value, and our rejection region will always be that area that is greater than F alpha. So your main job is just to find F alpha and state your rejection region. The rejection region is always the same. Reject H naught if F calculated is greater than F alpha. Okay, so you have to find that F alpha, because you have to state the value here. Don't just say F alpha, no, you have to state the value. F alpha, so our F alpha is given by F v1 comma v2, where v1, these are degrees of freedom. V1 is just given by k minus 1, and v2 is given by is given by n minus k. So our k is the number of populations. In this case, 3 minus 1, which gives us 2. Our n is just the sum of all the sample sizes. In our example, the first population has 3, the second has 4, the third has 2. So when you add this, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9. 9 minus k is 3, which gives us 6. So we have v1 is 2, v2 is 6. So we now move to the F table. So you look for the F table. Now the F table, the first heading on the F table is the level of significance, and that's given by 5%. You can see it there. So then after seeing the 5%, move to the v1 is 2 and v2 is 6. So our value becomes 5.16. That is our F value. So that means our F value is 5. Forgotten that value again. 5.14. So that means you're going to reject F calculated if you're going to reject H naught if F calculated is greater than 5.14. Okay. Now that you have determined the rejection region, our fourth step is to calculate the sample evidence. Now here, that's where there's a big difference, because the F is given by the mean squares between divided by the mean squares within. Now the mean squares between and the mean squares within are variances. When you look at this table, you have the online, physical, and both teaching methods. For the fact that the teaching methods are different, we call this difference between teaching methods the variation that arises from between treatments. Variation that arises from between treatments. We have online, physical, and both. Okay. Then look at the values within the online teaching methods. They are also different. And within the physical teaching method, we also have different values. So there are also variations that arise from the within the treatment. So we have the between variation and the within variations. So to find the F value, you're going to determine the variance that arises from the between treatments and the variance that arises from the within. Okay. So now I'm going to show you how to obtain these mean squares. So to find the mean squares, we first have to find the sum of squares between and the sum of squares within. So we're going to say the total variation. Actually, we start with the sum of squares. The total sum of squares is just given by the sum of squares between plus the sum of squares within. So the sum of squares between is just given by the sum of the sample size for each population, the mean for each population minus the grand mean. So the grand mean is actually just the mean of all the values regardless of their populations, and that's denoted by the x bar bar. It has double bars. Okay, so in this case we have n1. Our n1 is what? N1 is 3. So this is n1 x1 x bar 1 minus this plus n2 x bar 2 minus x bar bar squared plus n3 x3 minus that squared. So we now replace. So that means that we need to find the mean, the grand mean, and the mean as well. So the mean for population 1 will be 1 plus 3 plus 4. 1 plus 3 plus 4 divided by 3. 2.67. And for population 2, we have 1 plus 5 plus 2 plus 4 divided by 4. This is 3. Then we have 6 plus 7 divided by 2. 6.5. Then we need to find the grand mean. 2.67 plus 3 plus 6.5 divided by 3, 4.05. So x bar bar is equals to 4.057. Okay, so the first population has a number of 3, size 2.67 minus 4.057 we square plus this has 4, that's 3 minus 4.057 we square plus 2, this is 6.5, 4.057 we square. So when you do this, you're going to find the sum of squares between. Okay, now the sum of squares within is given by sum. It's a double summation xij minus x. So this just means that each value you subtract its mean and then you square. So we have 1, 3, and 4. So this is 1 minus 2.67 squared plus 3 minus 2.67 squared plus 4 2.67 squared plus the other values 2451 2451 2451. So this, the mean is that 2 minus 3 squared plus okay, then we have 6 minus 6.5, 7 minus 6.5. okay, so this will give us the sum of squares between. So after doing this, then you have to put across the Anova table. Okay, so this is the Anova table. Now this will lead us to finding the F calculated. So we start with the source of variation. Then the sum of squares, the degrees of freedom, the mean squares, and the F ratio. So here we're going to say between samples and the within samples. So here you put your sum of squares between, sum of squares within, the value that you would have found. The degrees of freedom for the sum of squares between is k minus 1, and this is n minus k. The mean squares between is just given by the sum of squares between over k minus 1, and the mean squares within is given by the sum of squares within divided by n minus k. Then the F value, the F calculated, is given by the mean squares between over mean squares within. So this value that you would have found, the F, is now what you're going to compare on step what? Step 5. So you either reject, or depending on what you're going to find, you either reject if it's more than, if it's greater than, reject if H naught is greater than 5.14, and then make conclusion. Okay, so this is the only difference. All the work that you have is on computing the sum of squares between and the mean squares and finding the F value. Once you just find it, then you either reject or fail to reject, whether it's depending on whether it's greater than your F critical, and in this case is 5.14. okay, so I think this is all that we have on analysis of variance. Please go through, it's not difficult, it's very easy. Yeah, so go through. I'm going to send the solutions for tutorial sheet 11. Okay, all the best and thank you.